This conference will now be recorded.
Good morning, guys. So yesterday we looked at fundamentals of Docker and Kubernetes. Now we know what is Docker and what is Kubernetes and what are the different building blocks or basic units or important components of your Docker and Kubernetes, and what are the different types of Kubernetes services you have, like managed versions, and then vanilla flavor means open source version, and then you also see turnkey cloud, etc., right? And you also see, based on the type of the Kubernetes flavor you select, your responsibilities will change basically. I mean, if you take custom, you have to do everything means infrastructure management and software management and application management as well. If you go with a managed version Kubernetes, like AKS, Azure Kubernetes Service, you are responsible only for your management of your applications. Basically, means you will do a CI/CD and deploy them to Kubernetes cluster. The underlying infrastructure of Kubernetes will be managed by Azure. Similarly, if you go with AWS, you call it as a EKS, as I told you. And you also seen these benefits are applicable for any managed version of Kubernetes, basically. Okay. Now, let's start with some simple commands. I would say these are must and should commands for Docker, right? So for any programming language or for any database, CRUD operations are must and should, right? Creating, reading, updating, and deleting. Be it a database, be it files, be it anything. These are the four operations that you do, wherever, I mean, any part of your life, basically. So similarly, here also you will have to create a image for the code given to you, and then from the image you need to build a container, and that container holds the application to be served, right? And then you will be required to update the images. Updating images is nothing but rebuilding. I mean, if you make some functionality change, you need to build it again, then the image will be updated. And updating container means you will again deploy that image. I mean, you convert the latest version of image into a container. So this is nothing but updating. And deleting is as simple as that. You remove the containers, you remove the images from the Kubernetes environment. Okay. But how do you build a Docker image based on your code? So you will build a Docker image based on a file called Docker file. That's what you see here. Docker file. Docker file is nothing but a simple text file. In the text file, you will keep all the commands that are required to create an image based on the code what we have. As simple as that. And Docker Compose is another Docker file. Okay. Uh, and you use it to make a connectivity between different Docker, I mean, between different images, because if you take any given application, it may have more than one image, basically at least two images, one for UI, one for some API, minimum two there will be there. Okay. Of course, if you are using static HTML websites, then it will have only one, one container is enough for that. That means one image is enough for that. Okay. uh, how do you write a Docker file? How do you learn that? All we see. Okay. So must know commands are pull, push, build, and run. Pull is nothing but, okay, you can always, when I'm talking about any commands or any concepts in Docker, you can always compare it with your regular way of working. That means when I say pull, you can you can treat it as a pull in your Azure repos, where you pull the code from the remote repository. Push means you will push the code from your local to a remote repository. Similarly, pull means you will pull the images from a remote repository. Push means you will push your image to your remote repository. Build means you will build an image for your code. Run means you will create a container based on the image built from the build command, basically. Okay. So as simple as that, you can apply your analogy like that. Okay, and there are a number of Docker commands available. Okay, I just taken this list from our Docker UI. I will show you in a minute, basically. Okay, yeah, I mean, you see a lot of things here. Okay, attaching, build, commit, cp means copy, create, diff commands, events, execution, listing the images, very popular, we need to use it, images, inspect, kill, load, all these things are commands, and it will be prefixed by docker space build, docker space attach, docker space exec, like that, basically. Okay, and you see how do you remove containers, that is using rm. How do you rename a container, how do you restart a container, how do you start a container, so how do you stop a container, so how do you tag some tags are nothing but your metadata, right, to identify uh, the resources. Okay, and how
So
do you,
now,
yeah.
container refers to the machine, the virtual machine.
Oh, sorry, I didn't hear you. Can you come again?
Does the container refer to a virtual machine?
No, no. See, okay. If you go back to previous slides, you need to keep this diagram in your mind, basically. You need to keep this diagram in always
Yeah,
mind.
yeah, okay, I got it.
So you have your physical server which contains your hardware, and then on top of that you have your operating system. On top of that you will install the Docker if it is a physical server, right?
Okay,
And inside the Docker you will have the containers. Okay,
okay,
if it is a virtual machine, how it looks like? Yeah, on the left hand side you can see you will have the hardware, and then operating system on your physical server, and you will have some hypervisor which you do not see. On top of that, we create a number of virtual machines, right? In that virtual
okay,
machine you will have the containers. That's what you see
okay.
here. You can see
So
here
it's
hypervisor. In a virtual machine you will have the Docker. In that Docker you will have all your containers running.
so can we relate to containers in parallel to virtual machines
Yeah, that's what minified
or
version of
something
your
like,
virtual machine.
yeah,
It's a
something like a
minified
blob
version of,
which holds. Okay,
exactly. Yeah, see, if you take a virtual machine, it is a partition in your physical server, right? And it
yes,
is logically partitioned by your hypervisor software. Logical partition, right? In your
yeah.
physical server. And in that physical server, you have your virtual machine. In that virtual machine, we are creating logical partitions like minified versions of your virtual machine by using the software Docker.
So
Docker should be installed on each and every server what you are using.
so what happens here is we will have only one virtual machine, but it will be devoted for different applications.
Yeah, exactly. If I have to show it in a different way, let us see.
Okay, instead of having one server for each of the application, we will have only single server, but the resources will be shared among the different application
Exactly.
virtual.
Let us say that this is a big server. Okay,
Okay,
physical server. This is how your regular environment works. Okay, people will have
okay,
physical servers. It is must. Without this, nothing will be there, right? Okay,
yeah,
and people will install uh, hypervisor. Okay, I mean different vendors use different softwares, but hypervisor is the base component. So you will have the hypervisor.
okay,
Okay, uh, let's see. Hypervisor software is installed. Okay, now this, I mean, you can think of it as a virtual, I mean, a VMware, because I don't know what Azure or AWS, they don't tell, right? That is a proprietary software. Now, what this hypervisor will do, it will separate or it will partition like this: VM1, VM2, VM3, VM4, like this. It will basically make a logical partitions. Now, let us think that it is having some 128 GB memory. Okay, and let us say it is having some 8 CPUs on this physical server. Now,
Okay.
1, 2, 3, 4, 5, 6. So if you divide it by 128 by 6, how much it will come to? Let us say some 20 partitions, right? If it is 8 GB, let us say you make it as a 16 GB. Okay, it will become 116 GB.
Yeah, 6 parts.
Okay, let us say 1 CPU. When you are talking about virtual machines, you call it as a vCPU, virtual CPU. Okay,
Yes.
and then you will have another 16 GB, and then one vCPU. Because I can't make more than 8 virtual machines because of the lack of the CPUs, right? I need at least one CPU for each machine.
Yeah, yes.
vCPU, vCPU, vCPU. Like this, your virtual machines are created basically. Okay,
Okay.
and inside this, everything is on the physical server. If you see, and inside this, what happens? Docker will be installed. Okay, like this.
Okay.
Okay. So I have the Docker engine, you would say, or Docker platform. Okay. Now what it will do? Here you can install the containers. That's what I shown you. Container one, container two, and container three. Now it has a 16 GB memory, right? Okay. Now how much memory I can give to each of this container? I can't give more than 16 GB. I can't even give at least some 30% of the memory should be useful for should be used for your virtual machine, and the rest of the 60-70% can be given to your virtual machine. Sorry, your containers. Let us say now for this these things, how much memory I can give. I mean, this is how memory allocation will happen basically. So let us say for this I can give, let us say, some 4 GB. Okay, 4 GB, 4 GB. Now you understand? I need to give at least 4 GB for the entire virtual machine because the entire operating system running on this virtual machine, right? Isn't it? Okay. This is how
Can
your
you can
physical.
you explain this Docker part once again? Only this
So
Docker part.
So I partitioned this physical server into virtual machines using hypervisor, right? So this
Yes,
is a
yes,
server administration concept and network administration. So your infrastructure concepts basically.
yes.
It is all about infrastructure. Okay. Now
Okay,
inside that virtual CPU, what I'm doing, I'm installing the Docker engine. Okay.
okay,
The way we install, I mean, yesterday I shown you Docker desktop, right? In the similar way,
yes,
you will install the Docker engine in all the servers wherever you want. Okay.
okay,
And when you install the Docker engine, I'm going to deploy the containers, right? When I deploy a
okay,
container into Docker engine, I need to give, I mean, as I said, your container is a minified version of your virtual machine, right? Your virtual
yeah,
machine is a minified version of your physical server. Your
yes,
container is a minified version of your virtual machine or your physical machine if it is a physical server. Now
yeah,
I need to give a CPU and memory as well to this container. Otherwise, how it will run? When I say it is minified, it also need a CPU and memory, right? That's where,
yes,
based on the availability of the memory in my virtual machine, I segregate basically. I divide. If I have three containers, I give a 4 GB, 4 GB, 4 GB. I leave another 4 GB for the virtual machine to work basically.
okay,
Now, now you see it is a minified version. That's what I always use that word, minified version. Okay, this is how
okay,
it works. Very high level.
yeah,
Okay.
okay,
Yeah. Okay. So you will have all these commands. Okay. Guys, once you install the Docker engine, sorry, Docker desktop, right? Yesterday I shown you how to you just need to install and you have to say yes, yes, yes. That's it. It will install your Docker desktop basically. Once you install, you will see. I mean, you can see this kind of desktop icon, Docker desktop. You can double click. Now actually your environment is having Docker engine running basically. See, I mean, before 2 years ago, it used to take 3 4 days to install and configure Docker engine on the laptop or any server basically. Now, if you take servers, right, server itself comes with a Docker engine. You don't need to, if you go to portal.azure.com, you can search for servers, and that servers will are already having the Docker engine. You don't need even installation of Docker basically. That I mean, we mature like that. Even now, even in our local laptop, setting up a dev environment is a matter of minutes. You simply download it and then install the Docker desktop. That's it. Your dev environment is up and running. Okay, now you see, once you install, when you open this Docker desktop, right? So you can see on the left hand side, uh, volumes is nothing but uh, your storage basically, your C drive, D drive, E drive. Because see, your containers are running from the virtual machine or physical machine, right? But containers are temporary. When you delete it, when you remove the container or delete the container, your storage will be gone. But if you need a persistent storage, means which should be available always, then you need to map the path in container with the path in your virtual machine or physical machine. That you call it as a volume. You can see this, you can create a volume basically. Okay, we'll talk about it. And then images. Right now everything is empty. Okay, once you create an image, I mean, this is a dev environment, right? Once you create an image from the Visual Studio, you can see that here basically. Okay, and remote repositories is again remote repository for your images. The way you have local and remote in your .NET code or Java code, in the same way you have a local and remote here as well. You see some ID, Purna 86 HYD. This is my Docker Hub ID. I will show you what is that. Since I don't have any images, obviously I don't have any containers running here. So what is this ID basically? You need to log in when once you have this Docker desktop installed basically. So this is my Docker Hub credential.
The login is just a normal login, or
It's a login of Docker Hub. I'm showing it. So
okay, it's
Docker
the
Hub is
same way like
a
we created Azure.
Docker Hub is the environment. I mean, portal created by Docker company, and who is the founder of this Docker environment, Docker platform basically. Okay,
Okay.
so we can keep our, I mean, be it a AKS, EKS, or your Kubernetes. Those are all just platforms, right? But actual Docker images are available in this hub.docker.com basically. Okay, let us say you are working on .NET application. You need the .NET runtime image, right? Of course you create image for your application. Let us say for your ASP.NET application, but your ASP.NET application need a .NET, right? .NET runtime. Okay, if
Yeah.
you and it needs IAS, right? But who will build those images? Not us, right? Those have to be built by the product vendor itself, whoever is managing those products, right?
Okay.
And you need some SQL server. If it is a regular SQL server, you will install on the server. But if it is a image, if you want to run it in a container, then Microsoft has to give that container, right? Sorry, image. So
Yeah.
they make all those images. All the vendors across the world build their images for their products and keep it in the hub.docker.com. Okay, that's what I say. So you can log in. If you don't have an account, you can create your account. Very simple. So I have my login already. I use my Gmail ID. This is I don't know. I forgot my password because I log in from there always. Uh,
This is free of cost, right?
yeah, this is my account.
Or
Okay.
should we pay for this if we log in, register?
The, yeah. So I already created. You can sign up basically. Once you create your ID, this is how it looks basically. Okay. You can create your the way you create repositories in your in basically your SCM tools. You will create repository here as well. Let us I'll create a repository. I will go and say the repository name is so this is my id, and inside that I'm creating my repository saying that uh, what is Bloomberg DevOps. Okay, and you can see you can is saying it must contain a alphanumeric. Okay, one
No,
letters
it's
must be
letters must be
lowercase.
in lowercase.
uh, and you give some description, and you can make it as a public or private. If you see, you can make only one private, maximum one private repository if you are using free account, because I'm using free basically. Okay, if it is public,
Yeah.
you can use any number. And whatever the image you create will be available for other users as well. Okay, and let us say
Okay.
create. Okay, my this is my repository basically. Okay, this is my account. This is always you refer to any image like this, your account slash and your repository. This is a convention. Okay, in Docker basically. And if you want to push, someone want to push an image, this is the command. See, this is a self-explanatory. But you need the guidance basically. You see, Docker push Purna HYD slash and net November DevOps one, and then tag name. This is how I can push any image here basically. We'll see. Okay, but I'm just so let us say now I want to have some .NET runtime, because I'm creating a image for my .NET application. So you will have your .NET runtime. You can go and search for images. ASP.NET 4
Okay.
3.1 runtime. So you see, an image is already built by your Microsoft. You see, by Microsoft, and this is a description, and you can see all the things. 100 million plus downloads so far. And this is what you see in the Nuget as well, right? Nuget.org is the place where you see all the reusable components, right? And the Azure
Yeah.
artifacts, you will see all the your reusable components, right? And Maven, you will see all the reusable components for Java. Similarly, Docker Hub is a place where you see all the images of any product vendor. Okay, now you see .NET. And these guys it's not a download, right? You need to pull basically. Okay, you will see all the reviews. Okay, and then resources. It will give you the documentation, etc. And let us say you can go and check, let us say SQL server. Where is you can say enter SQL server. You need to be very careful about images, because anyone can push their images, right? We need to see always the name basically. Who did that? Who created that image? By mistake, it's like fraud basically. People can push their images with a similar name. If you take it, probably you will download malware basically. Okay, you need to be
Okay.
you need to be careful. So so there will be. You need to go by. You can see it is Microsoft. What I said. It's better to Google always. SQL Server image. You see, it takes me there on Microsoft SQL Server. You can see, right? Microsoft SQL Server by Microsoft. So this is an official image. We call them as official image basically. This is a official image for Linux server basically, for Docker engine. Okay. If you want to pull it into your environment, you will use this command. Okay, docker image. You can say this.
Purna, one question.
Mhm.
So usually in production environments, we have a database on a different server and application on a different server.
Yes.
So in this case, would we have a one image for SQL and one image for IIS?
I will tell you. I mean, we did not come to that phase basically. Okay,
Okay.
it works in a different way basically. I will explain it. Okay, let's go
Yes.
one by one. Okay, so
Okay.
now you need to know the fundamentals before you go to the advanced stuff basically, right? Okay. Now, if you see whoever creates their image, right, they will give all the documentation. What is the version, latest version? How many versions are there? What is that image, and how to use this image? Okay, let us say, see, this is SQL server, right? Your SQL server at least should have your root user ID password, right? Okay, when you install it, you set it up and SA, right? SA user ID password for SQL server by default. How do you set them?
Yeah. Yes.
So if it is a regular, you install it and you start doing it, but it is a container, you cannot log in basically. To container you cannot log in physically, right? For virtual machine you can log into the server using your user ID password. For container you cannot log in because that is a logical of logical partition. Okay, now these are all the command that you need to say, use to set up your SQL server up and running. Okay, it will be clearly given. Okay, here, and how many versions are there, you see how many versions are here basically. Okay, so each and every image will be is well documented. All you need to is some patience to go through them basically. You see the tags where all it works basically. Okay, so this is important. You always need to go by the publisher, and it should be official image whatever you are using. Okay. Okay. So this is just preview basically, and so for our demo, I mean, I'm going to demonstrate creating image and deploying to Kubernetes. For our purpose, I'm not going to use Docker Hub as a this is a container registry. Yesterday, if you remember, yesterday I was telling container registry is one of the building block. Okay, so this is one of the container registries. I'm going to use ACR, Azure Container Registry, for my demo. Okay, I'm not going to use this, but for the development environment, I'm showing it to you basically, because that way I am showing two different tools for you. Okay. Okay. So if you want to work with the Docker, you can go to PowerShell and start working with. So go to PowerShell. You can run it as administrator as usual. See, once you install Docker, you need to verify if the Docker is installed or not. All you need to do is save Docker. If you are getting these commands, okay, if you are getting these commands in your laptop or a server, you can see it is listing out all the commands, right? If it is
Yes.
listing the command, that means the Docker engine is installed on your laptop or on the server. If it is not there, that means Docker is not installed. Okay, that's as simple as that basically. Okay, now
Okay.
uh, you can check basically if there are any images on this server. Okay, let me clear this. So let us say Docker images. So there are no images, it is giving me empty basically. So where how do I know? Basically I know all these commands, but for your benefit, I now put together all those commands here. I taken from there only, from the same UI. Okay, and I can log in. I mean, if I have some private repositories in my Docker Hub, I can log into my Docker Hub from here. Okay, and then start using the private repository. If it is a public, I don't need to log in. I can directly pull from here. Based. Let us say, let us think that MS SQL server, right? Uh, or else you can say, you can take SQL server itself. What is that? Or I want to take the smallest one basically. Okay. something is here MS. So how do I pull it? This is a public image, and this is official image basically. How do I pull it? I can simply use this command, copy this, and go to and paste it here basically. It's not copied. Sorry. So it will pull it from the okay. This image is for the Linux environment. You can see image operating system is Linux. It cannot be used on this platform because I'm having the Windows server. This is Windows server or Windows laptop. That's why it is saying I cannot download it. That's what it is saying. It is trying to pull it. Okay, as I told you, I mean you can see Docker keyword and then pull command, and this is the repository name, and this is the image name. Okay. Let me search for some Windows related images basically. Okay. So Windows IS. Okay. Now let me take this command and put here. It's not getting copied there basically. Copy. So Docker pull command, and then this is the repository name. Under that they have, they looks like they have some folder Windows. Under that they have the IIS. Okay. So now it is trying to pull it. See, now it is pulling. Looks like a little huge.
Puna, one more question.
Haha, yes.
So assume you allocated some physical space for for an image, like 3 GB or 5 GB, and if you want to
Yeah,
revise,
you will
can you
allocate
do it
space
for
for
the
the
full?
container. You will
Yeah,
allocate space for
container.
the container because container is the running version of your image. Okay.
Okay, so can we add or remove spaces for the container at a later time, like in the
Yeah, you
middle?
can update. You can update the containers. That's what is it.
Okay. So
So there will
the
be
other
set
question
of
is,
containers.
yeah,
Yeah,
one more
go ahead.
question. So when the application is running, uh, like when the application is live, there will be some transactions on the application, right?
Hmm.
Like insertions or deletions or updates, whatever it is. So the
That
more
is on
number
the
of
databases.
transactions,
That's
yeah,
on the
the
databases,
more,
right? Yeah,
yeah, database. So the more the transactions are, the more the database log file will be.
correct,
So the
correct.
log file will be increased automatically, and that will consume some of the existing space on the container. So do we have any feature where we can have some kind of alerts where maybe if the container space is around 90% used,
Yeah,
we will
exactly.
get an
Yeah.
alert to
Yes, yes. See, yesterday that's what I was saying. This is a minified version of your virtual machine or physical machine.
virtual machine.
Yeah, so you will have monitoring on the server, physical server, you have the monitoring on the virtual machine, and you have the monitoring on the container as well. Okay.
Okay,
There is no difference. You have the networking in the physical server, you have the networking in the virtual machine, you have the networking in the container as well. You have the
okay,
storage in your physical, you have the storage in virtual machine, you have the storage in Docker as well. But you call it as a volume. Okay.
okay,
Whatever
yes,
is applicable for your physical machine or virtual machine is applicable for your container as well, but it is a minified version. Simply understand like that basically. Guys, it is a very huge, it is taking a lot of time. You see, it is 1.5 GB basically. Okay. You see 1.18 GB. Okay. Okay, let it go on. Okay, it takes some time. Okay. But you see, I mean, it may come to, let us say, some 3 GB or something, but the actual IAS will be even more than that one basically. Okay. Okay. So I mean, okay, now guys, I am basically fast tracking because as I told you, this is a fundamental session, fundamental, but you will be knowing all the concepts and you can do self study. That's what I was telling yesterday or even start of the course as well. Now you know the commands, and but you need to build an image basically for your application. Okay, how do you build? I mean, let that go. We'll come back to this PowerShell basically. Okay, so where you are developing your code, you are developing in your Visual Studio, right?
Yeah.
Or you are develop if it is a Java, you are developing in the Java. I mean, Eclipse or there are many Eclipse and what is IntelliJ? That is another IDE that Java developers use. Okay, so let me create a project. For a simplicity, this time I will use a ASP web API basically API application, but ASP.NET Core. Okay, so I say ASP.NET Core. ASP.NET Core web application. You can say C Sharp, and it can work on Linux, Mac, Windows, etc. Right. Next, I'll say web API. I give some. I mean, just for identification. Just for identification. Okay. Create. So here you can create a web application. You can use Angular or React, etc. But I'm going to use only API for this purpose. And this is ASP.NET Core 3.1 runtime. Okay. I'm not enabling HTTPS. See, if you have the Docker desktop installed in your laptop or on the server, you can see this option: enable Docker desktop support. Enable Docker support basically. Okay. And it is clearly saying request Docker desktop. Okay. So what is the advantage of this one? It will create a Docker file for your project based on the template what you selected here. I selected a API template which is based on the ASP.NET Core 3.1. It will create a Docker file for me automatically. So, and I'm saying it is a Windows container because my local is Windows basically. Okay. Don't worry, the same image can be used for Linux as well. That's not a big deal. Okay, or you can say Linux, whatever it is. Say create. So it has no effect on the developer. Developer don't need to make any changes to their code. So it's all away from your I mean code basically. Away from means I mean developer need not to worry. Uh, you will have this file called Docker file. Hey, can you guys hear me?
Yeah, yes,
I'm
Purna.
still okay. Okay, I got it out. Okay, so all that happens is you will have a file called Docker file. Okay, and it doesn't have any extension basically. You can see it doesn't have any extension. Open this Docker file. Okay, so there are set of commands here to create an image by using this Docker file, and it is based on this code available in your project. If there are multiple projects, then each project will have a Docker file basically. Okay, but before getting into this one, let's understand some concepts. What I mean, the way you understood now, virtual machine, physical machine, virtual machine container. Let's understand how your application also looks like. Okay, let me go to my. So if you take any given application, right, this is how it looks like, right? If I start from the right hand side, this is browser, right? Means which we I mean, if you take a make my trip or IRCTC or any bookmark, any application, we access from the browser, isn't it? So browser, and it will when you hit that URL, it will go and hit some firewall of your company, and that company might have load balancer, because you will have multiple web servers, right? If it is one web server, it cannot handle the load, so you will have multiple web servers. And from here you will have a database servers, and you have a API servers, and you have middleware servers as well. Middleware means if you are using any Pega, etc., etc. Okay. And every server in their own network. DB servers will be in the DB network, and it will not be available over the internet. Only network that is available over internet is web front end servers, right? Front end servers. Okay. The rest, like APIs or middleware, most of the times it will not be available over the internet. Any request should come like this. Okay. And so this is it's a typical image, right? I mean a typical application view. Now when you come back to your image, okay, what your image requires. Let's see what your image requires. Let us say what your .NET application requires if you have to go and deploy it. Okay. So for your .NET application, you need some server operating system, because you need some server, right? And then
Yeah.
you need IIS, and you need a .NET runtime on the server based on the version of the .NET you are running. If it is a .NET Core, you need to install .NET Core. If it is a .NET standard, you need to install .NET a standard framework, that is .NET runtime. And then you have your application binaries, means your DLLs, reusable component DLLs, etc., or any docs. So you call them as artifacts or binaries, right? This is the minimum thing that you need, right, on any server, right? And similarly, so you go and deploy. I mean, you will have all these things on your virtual machine or physical machine. If it is a container, you still need all these things, right, in your container as well. You must need IIS. You must need a .NET runtime. You must need your binaries, and operating system obviously needed. But anyways, operating system will be. I mean, your Docker engine will give access to the kernel of your operating system to the container. So don't worry about it. But you need to worry about these things: IIS, .NET runtime, and application binaries. So when you are building an image for your application, you are going to pull all these, library, all these images from the Docker Hub. If so, many of the companies, what will do? Let us say companies like us. I mean, I'm working for some MNC, right? What we do, we don't directly pull from the Docker Hub. Let us say I need IIS. Okay, let us say I need a .NET runtime, right? But the .NET runtime is available in the Docker Hub basically, because every company will push their images here. But the companies, MNCs, will not directly pull from here. The reason, we will have a lot of fraud here as well, right? Many people create fake images as well. They give the same name, or some different name. As a new user, you don't know what is the difference, basically, which is the right one, which is the wrong one. So what MNCs will do, instead of pulling directly from here, we set up our own container registry internally, basically in our own organization. Okay. To that container registry, we will pull from here, and we push it to our container registry, and we will ask our developers, hey, go and take the images from this from our internal container registry. That's what we do, basically, or any company will do. Okay. That's a real time, basically. Okay. Now let's come back to our try to understand. Now if you see here, you need all these things minimum: IIS, runtime, and application binaries. Now that's what your Docker file contains. As I told you, Docker file will be used to create the image. Now what you see here, a command called from. Okay, what I'm saying, hey, from this repository mcr.microsoft.com /net, and this is the image. Last one is the image. Okay, download this image, ASP.NET colon 3.1 nano server image into your local server. And then what I'm saying, this is all with respect to your container. So I'm downloading this to my image basically. Okay. Set the working directory as slash app. So it has to be, I mean, there should be some folder, right, to keep all your binaries. That is a app folder. Slash app means, so guys, I don't know whether it is C drive or D drive in a container basically. So that's the reason instead of giving, you know, physical, I mean, we will get the what is a relative path. This is not absolute path. So a folder with a name called app will be created inside a image. Okay. And then if it is a, so we need to expose this service to end users, right? So because this is going to be running in the container, so I'm exposing this service on port 80 http 80. Okay, now I have the .NET runtime. Okay, and then uh, and you see this is a nano server. You can go and check it. What is this nano server basically? This is, I mean, as I told you, you need access to your operating system of the server, right? This image will make you provide that. You can go and search for it. This is how you can go and learn. Okay, so go and spend some time here. Okay, it will explain you. Okay, everything. And then I am downloading the SDK of .NET Core. You can see SDK 3.1. Okay, this is, you know, basically alias basically. Okay, base build. These are the alias because this is a bigger command, right? If I want to refer to this command in the later steps, I can simply use this base basically rather than writing the entire command. Okay, and then I'm again setting up another working directory, that is SRC. This will be under, I mean, this is another folder. Okay. After that, what I'm doing, I'm copying the code from my current, uh, uh, Visual Studio directory. Basically, this is my physical folder, right? If you go and see, right click, open folder in a file explorer. So you can see web API underscore Docker demo. Under that, I have my web API underscore Docker demo .cs project, right? You will have your .cs projects. You can see here, and that's what I'm saying. Hey, now you have the image for your .NET runtime. Copy your code as well to the to this folder web API Docker demo inside the container, and it will go inside this app SRC folder basically inside the container or image, I would say. And then you remember there will be some NuGet libraries, right? If you remember when we are creating our CI pipeline, we use that NuGet library task, right? NuGet restore. That's what we are saying. Hey, take everything, even all the reusable components. Okay, and then we are setting up. I mean, now we have all the content. Copy dot dot means everything from this working directory to the to this SRC folder basically. Okay, and then we are building the .NET solution using this Docker run command. .NET build, building this .cs prosh. If you are using Visual Studio, you don't know any one of these things, right? All you do is you simply go and build your solution like this. But since it is automation, you need to know the commands. These are the commands. These are standard. It doesn't matter whether you are using ASP.NET web application, API, or you are using desktop application. These commands are common. Okay. Now you build it, and then you will publish. You remember, if I have to deploy to IAS, I used to have this publish item, right? When I say publish here, I am basically publishing to my local my local folder. But you can see you can publish to container registry, you can publish to one of your virtual machine, you can publish to directly to IIS. But I was using publishing to some folder. That is similar to what you see here, publish. And finally, I'm telling my image, hey, the entire code is in the app folder inside your container, and this is in the publish mode. And if any request is coming to your container, that request should go to this DLL, because this DLL contains all the functionality that is required. So so this is a standard for any .NET application. All all will changes your project names basically. Rest everything will be same. Your DLL name will change. So this is automatic in Visual Studio or Eclipse. It will create it for you. And imagine if you are already having some application which is not containerized, okay, you can create that Docker file for that existing application on the fly as well. All you need to do is, let us say, let me go ahead and Visual Studio 2019. Let me take any one of our solution. Let us say email features.sl. So people are migrating from regular deployments to the Docker deployments, right? So when people are migrating to Dockers and Kubernetes, they need a Docker file. So for the people who use Visual Studio, it's very simple now. So all you need to do is right click on the project, and there should be option for enable Docker support or something. There will be option for enable Docker support. Let me, I did not use it recently. Huh. You go here, okay, add, and then you will have, what is that, add and then Docker support, like this. This is for a new one, so let me go here, add new item. I should get an option add support basically. Let me select sorry, this is a class library, right? It is not available over internet. Let me take a web application. Guys, I mean, class libraries will not be accessed by a browser or something, right? It is just a DLL, which will be used by some other application. So my bad. Okay, let me take this a web application or a API, anything accessible over internet, basically. Okay, let us say this microservices. Right now, if you see, I don't have any Docker file here. Right click, add. Now you see a lot. You see the Docker support. Ah, Docker support. It will add a Docker file automatically for you for this project, basically, based on the available that you have, content available. You see, new file is being added. You can see this. You see, based on this code, it is downloading a ASP.ASP.NET 4.8 Windows Server core. That is the image that it downloaded, and then it set up the working directory as a inet pub/www root, and then it copied all the code from our uh, from our local to Docker publish folder, basically. So this is how it looks. But if it doesn't work for you, it works most of the time. You can copy paste the other here, what is this one to there, basically. Okay, now if I run this, let us say that my Docker file is ready. If you run this, you can see the option here, Docker. It will open in a browser, basically. The I mean, it is a standard. this is the API, that's why it will open in a web browser. But you will see an image built from this basically, and that image you can see here. You can see just now created web API underscore docker demo. You can see how web API docker demo, that is my project name, right? It created a let me close this. Okay, let me keep only this Visual Studio. What is the image name that we given here? That is given here, web API docker demo. Somewhere it should be there. So basically it has removed that underscore and created a web API docker demo. Okay, automatically. When we create it manually, we give the name as well. Okay, but this is automatic. You can see web API docker demo is created and it is showing in use. Okay, and this is the image ID, and this is the size of your application or container 347. Okay, and it downloaded, you see mcr.microsoft.com/windows/server core/ias, because ias is required, and then asp.net runtime. Okay, and all this based on our docker file basically, what you see here from top to basically. Okay, and then this is the image in your local, and in containers, if you see, the container is already running on the 60476 port basically. Okay, if you go to your browser, you see 60476, and the API name is weather forecast. So this is a dynamic API 60476. Sorry, dynamic port basically. Okay, and but in your API or web application will run on port 80 or port 443, HTTP or HTTPS, but you are accessing from the 60476. So what it is basically, when you're using Docker containers, right, you will have two ports. One port that is being used by the that will be used by the user to access your application. The other port is internal to your container. Okay, let us say your where it is coming from, your request is coming from browser, right? Browser, right? From here it will go to firewall, some firewall I said, right? Something load balancer or firewall. From here it will go to uh, let us say that your virtual machine. Okay, from here it should go to your container, isn't it? Okay, and whatever you see 60476, what is that port number? 60476 is this basically. 60476. Our actual API is running inside this container on port 80. This is on port 80. So this translation, okay, the user request is coming from 60476, but this gets translated to port 80. This gets done by your Docker engine basically. Okay, because you cannot run a web applications or web APIs on other than port 80 and port 443. It has to be 443 or port 80 only. Okay, but from external it can be anything. Okay, so the conversion will be taken care by your Docker engine. Now if you go to your PowerShell, now if you go and look at list of all the images, clear it, Docker images. Now you see these are all the images that are available on your local laptop. Okay, this is your application image, the first one. The next one The list 2 and 3 are from the Docker Hub basically. Okay, you download it from there. And if you want to see the containers, Docker PS, when you say Docker PS, it will give all the containers that are running on your local machine. Okay, you see the container ID, and what is the source for this container ID? That is the image, right? Web API Docker demo colon dev is the image name. Because as I said, container is the running version of your image. Okay, the source is this image. Okay, and it has some run some commands to create this container, and it is created 20 minutes ago. Right now it is up from last 20 minutes, and you can see the ports here. 60476 is from the browser to port 80, and this is a TCP protocol. And the name of this container is web API underscore Docker demo. If you want to remove the containers, you can remove direct. You can use a command, or you can go ahead and go to your Docker desktop, and you can go and delete it as well. That's it. No container running. You can, if you want to delete it, you can delete these images as well. Or you can push, if it is a private repository, you can push it to your Docker Hub as well. You can directly push to from here to your Docker Hub. Access denied because see, I mean, I deleted that container, right? And your Visual Studio noticed that, and it is saying, hey, your container connection to container lost. That's why debugging is aborted, because I ran it from here, right? So guys, what we do, we'll create uh, we'll see some more features in the how to use Docker Hub tomorrow, and then we'll go to our Azure Kubernetes service basically, and we'll create a CI/CD pipeline for this given application, and we'll push it to Kubernetes and all tomorrow. This is just introduction to all the commands and the environment what you.
Sure, Guru.
Yeah. So I mean I can run it for another 20 minutes, but it will be confusing for you, so you cannot digest it. Okay.
Okay.
So
Okay.
tomorrow I will explain this, and then we'll create a CI/CD pipeline for your project. Because right now whatever you done from here is from dev environment, but you do not do this one, right? You do it from the CI/CD pipeline. Okay, that's what we say.
So, Purna, does all the developers need to have this configured on their machines?
Yes, yes, they should have it. Otherwise,
Or
see,
is it
the
like,
Docker desktop should be there.
okay, or can they do like, they will push the changes to the remote repository and only the DevOps engineer will configure
Yes,
it on
yes.
their machine?
No, so see, we will create a repository for them in the Docker Hub, or if it is a ACR Azure content, we will create one repository for them. Their see, they don't need to push it. We don't allow them basically. Okay, you already have the dev environment locally. You will test your image here simply by running your Docker here. Okay, once you are done it, you simply, I mean, there is no that's what I'm saying, there is no difference the way developer work basically. They continue to write their code as usual, and they, but when they check in the Docker file as well. That's it. Okay, if there are any mistakes in the Docker file, the administrator will take care of it when he is creating the CI/CD pipeline. Okay, uh, we will not ask developer to do all these things basically.
Okay, so where is the link between uh, the TFS path and the solution in the local machine that will be in the
TFS
Docker?
path,
Yeah, I mean, we
there is no
do
TFS,
like,
we are using Azure
yes, I
repos,
mean,
right?
referring to the repositories.
Yeah, see, your code is already copied to the image. That's what these commands are basically. I mean,
Yeah,
we'll
code is copied
explain.
to the image.
The code is already copied. Let us, I mean, the uh, image is self-contained, right? It will contain all
Okay,
the
I'll
information that it
okay, okay.
requires.
I'll rephrase my question. So code is already copied to the image, and and the developers will move their changes for the by providing the information in the Docker file. So
Yeah.
What I'm asking is there are multiple developers, they make multiple changes. So the changes will be available to the in the Docker, right? Docker image.
Yeah, yeah. That's the reason we see this is your
Fine.
individual. So this is your individual, right? But when it comes to the DevOps, you don't do it from here, right? You do it from the portal, and all the code should be available in your master, right? Your master or release repo,
Yeah.
isn't it?
Yes.
Not,
So
think
developers
of it
will
as a
be checking in their
think of it
changes
as a
in their
dev
master
repository.
repository. Okay.
This is a dev repository, but similarly on this project, some 10 developers are working on it. But if you remember, when I created a CI/CD pipeline, did I pull the code from your local repository? No, right?
No,
I
it
pull
was
the
from the
code from the
master
remote repository,
remote.
right?
Yes.
That remote repository contains everybody's code, right? All the developers' code. Remember
Yeah.
when you use a pull, push, sync? Why we use sync? Because everybody works on the same project.
Same
Okay.
project, same code.
Yeah.
Yes.
Your code is not available on my laptop now. Okay, my code is not available on your laptop, but when you push it to the remote repository, everybody's code is available on the remote repository. So when I create a CI pipeline, obviously I create from the remote repository, not from your local, right?
Yeah.
Yeah. And this is just a file. It doesn't care if you see, right. It only go and refer to the .cs clause. It doesn't care what is there inside your code basically. So simply go and take the project name and go and build it basically for creating an image.
Okay.
Okay, you will see tomorrow how we build it actually. See, there is no difference as I said. Okay, only the addition will be your Docker file to your project.
Okay.
Okay, okay guys, that's all for today. Even I have to rush. So we'll continue tomorrow. So we'll have, once this is done, we'll have some introduction session to, you know, infrastructure as a code using ARM templates. Okay, that is for the infrastructure DevOps. I told, right, application DevOps and infrastructure DevOps. I give introduction to infrastructure DevOps as well, and then we talk about some best practices, some some deployment patterns, etc. Those are the concepts basically. Okay, and then we can wrap it up.
Okay, good.
Okay, guys, thank you. Have a good day.
Yeah, thank you.
Thanks.